Hi everyone, right, I just want to talk to you a bit about lactic acid, why everyone thinks about lactic acid. Everyone thinks lactic acid builds up when you do exercise, but it doesn't exist. Okay, so I've drawn here for you a diagram of glycolysis, what actually happens in the metabolism to break down substances for energy. And you can see at the top, we've got glucose. So glucose is the main driver of glycolysis. Wherever you're getting your glucose from, whether you're getting it through gluconeogenesis from fats and proteins, or whether you're ingesting it from carbohydrates, your body will always go through the process of glycolysis. And glycolysis will change the glucose into pyruvate. Pyruvate will then go into the mitochondria, into the cells, and subsequently into the Krebs cycle or the citric acid cycle, tricarbolic cycle, whatever you want to call it. This is where we produce the chemicals like NADH2 and FADH+. Those chemicals will then go into the electron transport chain, you can see, go through all the processes of the electron transport chain to make ATP. And ATP is the molecule that breaks down into effectively energy. But what happens is ATP is adenosine triphosphate, so it's got 3 different bonds, and the body has to actually break down these bonds to produce the energy. So immediately it breaks them down into ADP, which is adenosine diphosphate, and the breaking down of these bonds then produces hydrogen. You can see all these free radical hydrogens over here. What happens then is there's a build-up of hydrogen within the bloodstream that the body has to contend with. Now, in an aerobic state, which is plenty of oxygen, okay, so you've got plenty of oxygen in an aerobic state, and the body is quite capable of being on top of all these free hydrogens and mopping them up as it goes. But without oxygen, what happens is the system backs up. So it backs up all the way back up to pyruvate. And then what people used to think was that from pyruvate, lactic acid was formed, which produced lactate and more free radical hydrogens. But that's not the case anymore. All right? So this diagram is actually wrong. So what I'll do is I'll scrub it out, change the diagram, and show you what actually happens. So none of this happens anymore. This is, we still don't have oxygen, but none of this lactic acid, all load of rubbish, doesn't happen anymore. Let's scrub all that out. Right? Anaerobic, so without oxygen. So when there is no oxygen, you know, it's the anaerobic system. And what happens in the anaerobic system is lactate is actually after pyruvate. So that's where lactate is in the glycolysis process. And lactate then, when there's no oxygen present or limited amount of oxygen present, what happens is lactate jumps in and starts to clean up all the hydrogens. So lactate then starts to mop up all these hydrogens. It's the hydrogen, the excess amount of hydrogen, that gives you the lactic acid feeling in your muscles. But then to combat this, you just need to either increase your lactic threshold, which you can do through training, or if you're going fast, slow down the process of your metabolism so that more oxygen is present and you can then get on top of the free radical hydrogens. So it's not lactic acid, it's not a lactic acid buildup, it is too much hydrogen. And like I say, to combat it, all you need to do is build up your lactate threshold through training so that your lactate is able to mop up more of those hydrogens, or you can to increase the oxygen and have a better concentration gradient of oxygens to hydrogens.